All right, Algebra 1B. Welcome to part 2 of lesson 8.1. Today we're going to talk about polynomials. Yesterday we dealt with monomials. And just a reminder here, a monomial is a real number, a variable, or a combination thereof, real numbers and variables, with all whole number exponents. All right, remember there's just one of them when it's a monomial. Now, today we are going to focus on polynomial. So here's the first vocabulary word to add to your notes. Polynomial is some number of monomials added together, or it could just be one monomial. So it's one or more monomials from yesterday, all added up and put together. Okay. For example, 3x to the fourth plus 5x squared minus 7x plus 1. That is a list of 4 different monomials, 3x to the fourth, 5x squared, negative 7x, and 1, all added together. Right? And then we need to talk about 2 things when we discuss polynomials. The first being degree. Just like we talked about degree yesterday with monomials, being the exponents, I should say, of the variables all added together. Now, when we look at the degree of a polynomial, right here, degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. All right, greatest exponent is the one we're looking for. So, for example, the degree of this example up here is 4, because that is the largest degree out of any of my 4 monomials. Okay? So the degree of the polynomial is whatever is the largest exponent that you have, or the term with the highest degree. Okay? The other thing that your book introduces here is what's called standard form. Standard form of a polynomial means the degrees of the monomial terms decrease. So that means highest degree on the left, next highest, next highest, next highest. Okay, so we go from 4 to 2 to 1 to 0 here. All right? So that is in standard form because our degrees for each monomial is decreasing as we go from left to right. Okay. So your first job is to add those 2 vocabulary terms to your notes. Standard form of a polynomial, right here it's underlined. The degree of a polynomial, right here it is underlined. And the important part there is greatest exponent. So pause the video, add those 2 to your notes. Then we will go on to name and classify polynomials. All right, a little more notes to take here. Now I want you to add this table to your notes, because this is what we're going to use to name a polynomial. And we're going to name these polynomials based on their degrees and the number of terms or number of monomials that it contains. All right. For example, if the polynomial is just one term, number of terms 1, we call that a monomial. That's what we talked about yesterday. If the polynomial has 2 terms, we call it a binomial. Bi means 2. Bicycle has 2 wheels. Binomial has 2 terms. 3, then, maybe it makes sense, is trinomial. Tricycle has 3 wheels. Trinomial has 3 terms. Okay, those are the 3 that we are going to be concerned with. 1, 2, and 3. Monomial, binomial, trinomial. Anything beyond that, we don't have to worry about the name. Okay. Now, in terms of the degree, as we can see, our degrees here are increasing. Here we have 6, so that degree is 0, so we call that a constant. Constant monomial, meaning no degrees, no letters with exponents. The next example down here, 5x plus 9, that has 1x on it, right? X to the first power right there. So when our degree is 1, we call that a linear polynomial. All right? Here, next one down, we have an x squared. So 2 is our highest degree. When your highest degree is 2, you call that a quadratic polynomial. Quadratic polynomial. Okay. When it's 3, when you have something to the third power, you call that a cubic polynomial. And anything beyond that, for example, here 4, you just call it a 4th degree. Or 5, we just call it a 5th degree. All right. So again, 1, 2, and 3 are what we're concerned with. 1, 2, and 3 in terms of degree, and 1, 2, and 3 in terms of number of terms as well. All right? Your job is to get this whole blue table, which you can also find in your book on page 487, into your notes. Pause the video, get this guy into your notes, and then we will move on to our 2 example problems for today, and then we will be done. All right? Okay. In your homework, you're going to be asked to classify polynomials. Write each of them in standard form. There's one piece. Write it in standard form, meaning your degrees will decrease from left to right. What is the name of the polynomial based on 2 things? Degree and number of terms. Okay, so here we're going to use our table for that naming piece. Your first example here, letter A, says 3x plus 4x squared. Now, the degree of 3x is 1, and the degree of 4x squared is 2. So when we want standard form, we will flip that order around so that the monomial or the term with the higher degree comes first. 2 and then 1 instead of 1 and then 2. So here's our first answer. 4x squared plus 3x is written in standard form. Okay. Now, based on its degree, the degree here is 2, right? Our highest degree is 2, which means we have a quadratic polynomial. That comes from our table. When the degree is 2, we call it quadratic. And because there are 2 different terms here, a 4x squared and a 3x added together, 2 terms from the right-hand side of your table means binomial. So this is a quadratic, meaning degree 2, binomial, meaning 2 terms. All right? Over here, we have a kind of more complicated example, which is 4x minus 1 plus 5x to the third plus 7x. All right? Now, the degree of 4x is 1, right, because it's 4x to the first power, minus 1, which doesn't have any letters, so it's a 0, plus 5x to the third, that degree is 3, plus another 7x, that's 1. Okay. Now, we're going to rewrite those in order so that our degrees decrease from left to right, which means 5x to the third needs to come first. Then we will put together our 4x's and our 7x's to make 11x's right there. That comes next. And finally, our degree 0, our constant at the end, is our negative 1. Okay. So now we will take this standard form here, always decreasing degrees, right? 3, 1, 0. And since I see 3 different terms there, I should know that that is a trinomial. 3 terms, trinomial. And the highest degree that I have is a 3. And when the highest degree I have is 3, we call that cubic. So this is a cubic trinomial, that guy right there. Cubic trinomial. Degree 3, 3 terms. All right? Now, The only other thing that we need to do with these polynomials is adding and subtracting them. Okay? When you add and subtract polynomials, you are only allowed to add like terms. Please, please, please add that to your notes. You are only allowed to add like terms. All right? Add or subtract them. You cannot add and subtract things that have different variable pieces. An x squared and an x, for example, cannot be added. Now, here's an example, word problem example, that is not as complicated as it looks. So let's go through this together, and then we will talk about how we should add these polynomials. This says, a researcher studied the number of overnight stays in U.S. National Park Service campgrounds and in the backcountry of the National Park System over a 5-year period. The researcher modeled the results in thousands with the following polynomials. So here we are, negative 7.1x squared minus 180x plus 5800, that was the campgrounds polynomial, and 21x squared minus 140x plus 1900, that is the backcountry's polynomial. Okay. Each polynomial, when x is 0, that's the first year of the 5-year period. Okay. So if we went out to 5 years, x equals 5, that would be the end of our study. Now what they want us to do is total up the numbers for campgrounds and the backcountry. So all they want us to do here when it says total number is just add them. Plus them together. Okay? And that's what we're going to do. The way that we add polynomials, pretty simple. 2 steps. 1, line them up vertically, and then add the coefficients. All right? So you line them up vertically, your x squareds over top of your x squareds, your x's over top of your x's, your constants over the top of your constants, and so on and so on. Okay? Now, when we do that, all we have to do is add then, straight down, just like we normally would. Negative 7.1x squared plus 21x squared. If you did that on a calculator, we'd get 13.9x squared. Negative 180x and negative 140x, if you put together those two negatives, we're already negative. Going further in the negative, we get negative 320x. And then positive 5800 plus positive 1900 gives us a positive 7700 right there. Okay? So this would be our answer to the addition for those two polynomials. Okay? We have an x squared piece, an x piece, and a constant piece as well. Now, just briefly, I want to look at subtracting polynomials, and then I will ask you to do a couple, and we'll be ready for our practice problem set. They want to know what is a simpler form of this. X to the third minus 3x squared plus 5x minus 7x to the third plus 5x squared minus 12. Okay. Now we're going to be subtracting these two polynomials, but we're going to do it in very much the same way. We're going to subtract vertically. Okay. And in order to do that, we just line up our like terms. Line up your like terms on top of each other. So I can see that I have an x to the third in the first polynomial, and I have a 7x to the third in the second polynomial. Yes? And then I have a negative 3x to the second in the first polynomial, and a positive 5x to the second in the second polynomial. Okay. And then we have a positive 5x in the first polynomial, and no x term in the second polynomial, so I leave that blank. That is blank. Same thing with my numbers. I do not have a constant term in the first polynomial, so I leave that blank. And then I have a minus 12 in my second polynomial. So now from here, I can do this subtraction right away. I don't even need to do this step, and I will show you how. All we need to do is just subtract the bottom from the top. So 1x to the third minus 7x to the third, we get negative 6x to the third. Yes? if I have negative 3x squared and I'm minus 5x squared, negative 3 minus 5 more gives me a negative 8x squared down here. Right? Positive 5x squared minus 0, I'm not taking away anything from my positive 5x. Sorry, that's positive 5x, not positive 5x squared. So I'm just left with exactly what I had, plus 5x. And then with my negative 12, I have 0 minus negative 12. 0 minus negative 12. Okay, 0 minus negative 12, that turns into a positive 12. So my answer is negative 6x to the third minus 8x squared plus 5x plus 12. Okay. Line things up vertically, then subtract or add the opposite for each term. All right? Your job is to look at page 489, right in the middle, page 489, and find for me, please, the simpler form of this expression. So again, line up your like terms. Step 1. Line up like terms. Step 2. Subtract. Okay? Once you have that completed, you are ready to go on your practice problem set tomorrow. If you have any questions, I know this was a lot in one video, so if you have any questions, please make a note to ask me in class tomorrow. Otherwise, I will see you tomorrow. Have a wonderful night.